We're going to move over into the subject now of glycans, which are reported to be supporting a lot of the inflammatory issues associated with diseases. So we've got Gordan Lauc of GlycanAge coming to join us here. So Gordan, are you with us? Gordan, there you are. Great.
I am a Chief Scientific Officer of GlycanAge, but I'm also professor at University of Zagreb and a couple of other universities, but also founder and owner of GlycanAge Glycoscience Research Laboratory, which is a private research institute where we do most of the glycomic things we do. And GlycanAge as a company is a London-based startup. We started selling direct to consumer early this year, late last year. We did some business-to-business sales before. We have one product. This is the GlycanAge test, which is one of the tests of biological age. And it was developed in my other company, the GlycanAge Research Laboratory, based on over 100,000 people that we analyzed and over 10 million euros investment we got to do this research. And it's So it's all about glycans. And glycans are the ultimate layer of molecular complexity, but in the same time, they're the most neglected molecules of cellular communication. And this became very prominent in this COVID pandemics, when even the director of NIH was tweeting about the glycoprotein, the S-glycoprotein, without a single glycan on a structure. Actually, it looks like this. And these glycans are not only decorations, they're the functional parts of the molecule. They take part in interaction with the receptors, and they are important. And you cannot understand the function of this protein without also knowing the structure of a glycan. And majority of proteins are glycosylated. And this is not something I'm claiming. There are strong policy documents in both Europe and US claiming that. And actually, there is even a centerfold of New York Times 2 days ago with with all the glycoproteins on the surface, especially the S-glycoprotein, the glycans finally attached to the structure. So glycans are important, but unfortunately people don't study them enough because the technology is complicated and not so many labs can do it in high throughput. And my main company, GlycanAge, is the leading lab for glycan analysis in the world. We analyze over 150,000 people from some of the best clinical, epidemiological, and genetic cohorts there are in collaboration with all the leading research universities in the world. And one of the first things we learned is that glycans highly correlate with age. When we are young, at least immunoglobulin glycans, when we are young, we mostly have structures like this, which are known to suppress inflammation. So they're kind of suppressing low-grade chronic inflammation. And as we get older, there is less and less of these structures which suppress inflammation, and there is more and more of structures like this, which activate complement, which activate inflammation. And actually, just based on these glycan structures on a single molecule, you can develop a clock which predicts chronological age not too accurately. Approximately 9 years is our prediction of chronological age. But chronological age is not fun because we all know it. What is important that the difference between the chronological age and the age we predict based on glycans is explained by all the biomarkers of unhealthy life. So if you live a healthy life, your glycan age goes slower. If you live an unhealthy life, your glycan age goes much faster towards old age. And this same happens in a disease. These are different disease cohorts. Last 4 is just aging. So this is the effect on bad glycans and good glycans with age. And if you have any of these different diseases we studied, you look older. So your glycans move faster towards the old age. And this actually includes COVID-19. This is still unpublished, but we are submitting a paper these days. If you have a severe COVID, you will have more of bad glycans. And these are Bergamo, Barcelona, and Porto cohorts. And you will have less of the good glycans if you have severe COVID. And we are trying to understand how and why this happens. So we did a series of GWAS papers, published over 10 of them so far, and we mapped a network of over 40 genes which work together to regulate IgG glycosylation. And these genes are at the same time known risk factors for a number of different diseases and traits. Over 94 of them are highly pleiotropic with the genes which regulate IgG glycosylation. So based on that, we developed this GlycanAge index, which is a biomarker of biological age, which quantifies functional effectors of aging. So molecules that actually do the damage, they cause the low-grade chronic inflammation. And this is integration of genetic baseline, approximately 50%, epigenetics, and also actual environmental factors, which decide whether you will have young, anti-inflammatory glycans or old pro-inflammatory glycans in a given moment. And the big picture behind all that is, can we change it? Can we change glycans and prevent disease? Because we know these glycans actually do the damage. And if we can, then we do not have to wait until people become ill, when their disease is so developed that actually we cannot cure them anymore. And then they have something we call a chronic disease. And if we find this early by detecting biomarkers which do the damage, maybe a simple preventive intervention, lifestyle intervention, simple pharmacological intervention can return people to the healthy path. I will show you just one example, and this is the cardiovascular diseases, where our large cohort studies did with the colleagues from UK identified that IgG glycome associates with the cardiovascular disease risk score. So glycans today predict whether we're going to develop diseases, cardiovascular diseases in the future. But the question is it just correlation or is it causation? At least in animal models, we show that this is actually causation, that bad glycans can cause high blood pressure. And if you feed mice with a simple precursor for salicylic acid, you can have obese mice, but without development of hypertension. So you improve IgG cellulation, mice get fat, they do not develop hypertension. So it seems, at least for hypertension, bad glycans are actually causative. You can change them. You can change them, for example, by bariatric surgery, extremely efficient. Some people got younger up to 30 years in 6 months after surgery, but bariatric surgery is not something each of us would like to do. So is basic weight loss something that works? We studied 2,000 twins over 20 years in 3 time points. Twins which are gaining weight were aging faster than twins who are actually losing weight. So weight loss works, but there is no magic solution. We tried 1,000 people on 5 different diets, and each of the diets helped some of the people and did not help some other people. So in general, yes, diet helps, but you have to find which diet actually works for you. The same thing is for exercise. If you exercise too much, it's not good. If you exercise in the wrong way, it's not good, but if you exercise in a good way, you can have very quick reduction in these bad glycans and improvement of the good glycans. Some biohacking approaches work. We have, for example, Joe Raffaele in New York. Nearly all of his clients are 20 to 40 years younger men, 10 years younger women, which works. Some kind of biohacking approaches also work. So some people who are very old chronologically can be very alive biologically. And we see this in the biological age clock. We use the GlycanAge clock. This is anecdotal. This is not proper science, but we are trying to do proper science behind it. So we did it already for estrogen. We did a proper placebo-controlled randomized trial and showed that when menopause was chemically induced, women became on average 30% older within a couple of months. If there was estrogen replacement, this did not happen. This is estrogen replacement, this is the recovery period. So estrogen can rescue that. We did a large cohorts to study whether this actually associates with the lifespan. We don't have many people who died who did the GlycanAge test, but we did many different countries in the world, and expected lifespan is more or less on a line with our glycans. And so when you live in different countries, your glycans are different, and they're kind of practically on a line with the expected lifespan, which is a bit scary. So if you are living in a country where expected lifespan would be 40, 50 years, your glycans would become old very quickly compared to some longer living countries where it would move slowly. So to come to the close of my talk, GlycanAge is based on molecular effectors. So it's actually measuring molecules which do the damage. And it's very simple to quantify, at least for us. And it predicts future disease development. We have many papers on that. It responds to different types of intervention, and it strongly associates with expected lifespan. And just to finish, most of the research is of course not done in a GlycanAge. It was done in my other research company with the multiple research grants. We got over 15 million to different funding agencies, for which we are of course very grateful. And thank you for your attention. In exactly 12 minutes, I was done.
That's very good, Gordon. Thank you. And I understand that you're now in the market, Gordon. So how's that going for you? How's the commercialization of your work?
So we start, maybe I can stop sharing. So we moved to direct to consumer early this year. We have very high growth at the moment. We have more and more people starting to buy. We are profitable at a small scale, this company is, and it's easy for us. So we are growing organically. We didn't take any capital from anybody yet. We are talking to some people, but since we don't have a money problem, we are at the moment growing organically, but of course, interested for people willing to collaborate or more for people willing to work together with us to actually test people and try to help people to live a healthier life. Because we all know that what we should be doing to live longer, healthy life, but we don't do it. We don't do it because the feedback comes after 20, 30 years. But with our subscription model, where you do a test every 3 or 6 or 12 months, you get the feedback immediately.
And what type of people are buying your tests? Do you have a demographic that's the most popular?
At the moment, most of the people who are buying are this biohacking community. They're early adopters because you probably never heard about the GlycanAge until we applied to present here. So glycans are not really popular among people. And when you go to any MD or scientist, they would not know much about glycans. So it takes time to educate people. But for the moment, this biohacking community likes it because we can measure whether what they're doing actually works.
Excellent. Well, I wish you all the best, Gordon, with your business, and you're going to be taking some questions probably in the breakout room. So thanks very much for your presentation today. That was very succinct.
Thank you very much for the time. Thank you.
Awesome. Thank you.